All right, so let's get going on today's class. So what we're going to be doing today is we're going to be taking a look at Chapter 1, and specifically we're going to take a look at how do you display groups of numbers, groups of scores using tables and graphs. So this is a very important concept, very important idea. We are going to be using these ways of showing distributions throughout the semester. So we'll be covering it today and using it literally for the entirety of the semester. So we're going to start off with a brief look at descriptive versus inferential statistics. First portion of this course is going to be mostly descriptive, second portion mostly inferential, so we'll be sure that you know what those two are. And then we're going to introduce the idea of frequency distributions, and then take a look at the main two ways of displaying those, which is frequency tables and histograms. And then I'll have something to say about homework assignment number 2, and we'll have a portion of the class this time left over for practice time. All right, so once again, right now we're building up our fundamental skills, the basic skills that we're going to need to later on do all the cool things that stats can do, answer all the very interesting psychology questions that statistics allows us to tackle. But for right now, we need to make sure that we get our fundamentals in and get our practice in. So on that note, be sure that you are taking advantage of all the opportunities to practice. Make sure you're doing your pre-test, make sure you're doing your post-test, your in-class practice, complete any extra practice, homework assignments as well, to make sure that these concepts and these ideas become very, very automatic, so that when we start piling new ideas on top of those, you have that foundation laid out, you have those fundamentals ready to go, and you can access the new material. All right, so let's get to the first topic, descriptive versus inferential statistics. So right now what we're going to be doing for the next few weeks is descriptive statistics. And what descriptive statistics are is these are the procedures that are used to organize data, to summarize data, to simplify data. Basically, it's the procedures that are used to take a whole bunch of data that our human minds just cannot analyze and boil it down to a little bit of data that our human minds can make sense of. So let's say that you were doing a study in sports psychology and you wanted to know the effect that participating in sports has on resistance to mental disorders in a person's life. So you might take a look at basketball players, and you could collect data on this particular basketball player, this little child right here. You could collect data on this college basketball player here. You could collect data on this high school player right there. And you could also collect data on this recreational player out here who doesn't look too happy that he's on the sidelines. And you would collect data and data and data and data and data for hundreds, maybe thousands of different individuals and get a lot of raw scores. Descriptive statistics are the ways that we can understand those raw scores. It's taking those raw scores and boiling them down, usually to one number that our human brains can then make sense of. So the descriptive statistics that we're going to start introducing over the next couple of weeks, one right today with frequency distributions, is a way of taking mounds of data that our human minds just can't make any sense of and putting them in a format where we can look at them and say, oh, okay, I understand now, I get it, I know what's going on. Now, descriptive statistics are going to be used later on to help us out with inferential statistics. And inferential statistics, they're the techniques that we use to go from samples, which we have access to, and make generalizations about the population. So it turns out that humans will either tend to overgeneralize or undergeneralize. Generalization is something that is very difficult for a human being to do without interjecting all sorts of biases into how you generalize from a sample. Basically, if your sample shows you what you want to see, you're more likely to generalize that to the population. If your sample shows you something that you don't want to see, you're less likely to generalize that to the population as a human being. However, That's why we hand it off to statistics. And statistics has techniques to take out the bias so that we know as psychologists how to make proper generalizations. So when we have that descriptive data and we've studied those 100 basketball players, we can then decide whether what we found generalizes to all of the basketball players or whether or not what we found is specifically only for our sample. And again, this is a decision that we need to make as psychologists because we'll always only have access to a sample. You never have access to an entire population. You only ever have access to a sample. So we need to know how to intelligently decide whether our sample is going to generalize and what we found is going to generalize to the greater population, in which case we're going to be helping millions of people, or if what we have in our sample does not generalize, in which case we're going to avoid harming millions of people. So that decision needs to be made, and that's what we're going to be doing in the back half of this semester when we're doing inferential statistics. All right, so let's start off with some descriptive statistics with our introduction to frequency distributions. So frequency distribution, we got one shown right up there. This is an ordered listing of the number of individuals that have a particular score on a particular variable. So it's an ordered listing. That's one of the first ways that helps our minds understand these numbers. So we put the numbers in order. They're in order of, for example, increasing scores. And then we represent somehow the number of individuals that have or scored each of those different values for a particular variable. So for example, as an educator, oftentimes I'll take a look at a frequency distribution of test scores. So if this is hypothetical data, but I might say to myself, all right, on test number 1, what are the possible scores? So the possible scores in order, they're represented here on that x-axis. So it's possible to get 0 to 9%. It's possible to get 10 to 19%. It's possible to get 20 to 29%. Possible, all the way up to 90 to 100%. All of those are possible scores. And then what this frequency distribution here is visualizing is how many individuals achieve each of those scores. So each of these bars here, the height of the bars, indicate how many people that we measured scored that particular score. So first we can see that the places where there are no bars, nobody recorded those scores. Nobody got those particular scores. So nobody scored 0 to 9. Nobody scored between 10 and 19. Nobody that we measured scored between 20 to 29, 30 to 39, or 40 to 49. But we got a bar on 50 to 59. And the height of that bar indicates how many individuals achieved a score in that category. So when you take a look at a frequency distribution like this, one of the ways to think about those bars, one of the ways to conceptualize them is to think of them as apartment buildings, where one person lives on every single floor. So here we got an apartment building, and we got 2 people living in that apartment building. 2 people scored a 50 to a 59. On the next building over, we have 1, 2, 3, 4, 5 individuals stacked on top of each other in that apartment. 5 individuals scored 60 to 69. Right next to that, we got 4 individuals who achieved scores between 70 to 79. And then continuing on, we got another tall apartment building with 5 individuals who achieved a score between 80 to 89. And then lastly, we got 1 individual who achieved a score between 90 to 100. So this is a frequency distribution because these scores have been ordered. So you can't live wherever you want. You can't just jumble up, the apartment buildings. You live in the apartment building where you scored. And they represent how many individuals achieved each of those particular scores. So these frequency distributions, it's very important as we go through to remember, make a note of what each part of the frequency distribution stands for, so that you then later on know how to interpret each of those frequency distribution. So again, in this one, the scores are the possible scores, not necessarily the scores that people achieved, just the scores that could be achieved. And then the height of the bars are the number of individuals that actually attained any particular score. All right, so frequency distributions, they're typically structured as either a table or as a graph. So we just saw one that was a graph. The other major way of showing them is through frequency tables. And we're going to take a look at both of those because both of them have sort of pros and cons. Some of them are, tables are easier for one purpose, graphs are easier for another purpose. So we'll get to learn both of those just so that we can kind of see how we would construct those and use them. All right, let's start with frequency tables. First off, let's consider the following 20 scores on a 10-point quiz. So that capital N symbolizes how many scores you have. So whenever you see N in statistics, that's our terminology for number, I guess. It's the size of your set of scores. So if you see N equals 20, that means you got 20 scores. N equals 15, you got 15 scores. N equals 10,000, you got 10,000 scores. So we got 20 scores on a 10-point quiz. There are the scores. And it's very difficult for our human minds to take a look at those scores and know what to do with them. So if we were to take a look at that and say, people that scored under 5 need to go to tutoring. How many people need to go to tutoring? It's difficult to take a look at that. If we said to ourselves, people that scored 8 and above, get a special bonus on their next assignment. How many people are going to get that bonus? Again, very difficult to answer those questions with the scores jumbled up the way that they are. So we need to do some descriptive statistics and construct a frequency table of these scores. So this is what a frequency table, the headings for a frequency table are. We got F over here, that's frequency. When you see that small f, again, try to read it as frequency because f statistically is meaningless, but the word frequency to our human minds is meaningful. So read that as frequency. And then the X over here stands for scores, but I will warn you, this is foreshadowing, this is upcoming red flags for possible disaster. There's a bit of a trick there. It's not the scores, it's the possible scores. So when you're dealing with X regularly, normally, read it as the scores. But when you're dealing with it in a frequency table, please get into the habit of saying, oh, it's a frequency table, possible scores. All right, so it's the same X. I wish they just put like question mark X, for possible scores or something. I wish they somehow differentiated it. They don't. So just know that in everything else in statistics, that X means your scores. So that X normally would stand in for all 20 of those scores. But on a frequency table, that X stands for possible scores, not the actual scores, the scores that are possible. So just make a note of that somewhere, and I'll show you one of the issues that can occur if you forget about that distinction. All right, so we got the possible scores, and on your table, you would list all the possible scores when you construct your table. So 10 is a possible score. It's a 10-point quiz. You can get a 10. You can get a 9. You can get an 8. You can get a 7, a 6, a 5, a 4. But these were automatic at one point. A 3, a 2, a 1, or a 0. Those are all the possible scores. Those go into that X column, that possible score column. And then what you need to do is you need to start filling in the frequencies. How many scores are there of each of these possible scores in your data set, in your set of scores? So let's zoom in on those so we can see this a little bit easier. And what we do is, when we're constructing this table, we scan our scores and we look for how many zeros are there. How many people out of the 20 achieved the score of 0? And we can see that nobody achieved the score of 0. So the frequency is entered at 0. So this means that 0 individuals scored a 0. We do the same thing for number 1. How many people scored a number 1? Nobody scored a number 1, so the frequency is 0. How many scored 2 out of 10? Well, for that, we find one individual scored 2 out of 10. A second individual scored 2 out of 10. So we have 2 people scoring 2 out of 10. The score of 2 occurs with a frequency of 2. 2 individuals achieved 2 out of 10. How many achieved 3 out of 10? Well, we got one right there. We got one right there. Once again, 2 individuals achieved the score of 3 out of 10. The frequency for 3, a score of 3 out of 10, is equal to 2. And you keep doing this for every single score. So you do it for a score of 4 out of 10. We got 2 individuals scored 4 out of 10. You do it for 5 out of 10. We got 2 individuals scored a 5 out of 10. You then go to 6 out of 10. Just one person scored a 6 out of 10. 7 out of 10, we got 1, 2, 3, 4 individuals scored a 7 out of 10. 8 out of 10, we got 1, 2, 3 individuals scored 8 out of 10. 9 out of 10, we just got the 1. And then finally, we got 1, 2, 3 individuals that scored 10 out of 10. So that is how you construct a frequency table for those scores. You take the scores, count up how many of them are in each possible score, and enter those into the frequency column on your frequency table. One way to check whether or not you did this correctly is to then add up your frequencies, and it should add up to the number of scores that you have. So when you're doing this with your homework, if you're using Excel sheets to do that, remember the sum function that we introduced last time. You can just take your frequencies, sum them up, and if your summation, if your total frequency equals the number of scores that you have, chances are you've done it correctly. If it doesn't, you made a mistake somewhere. So use that as a double check just to make sure that you're doing things correctly. All right, any questions so far on constructing a frequency table? All right. So this is, once again, it's useful to have this frequency table. It's easier than answering questions about the unorganized data. So for example, if I was to ask myself, as an instructor, if this was the performance in one of my classes, and I would say, well, anybody that scored 5 or less has to come in for a tutoring session, right? Anybody that scored 5 or less has to come in for a review session. How many students are going to be coming in? Well, nobody scored 0 out of 10, so we got 0. Nobody scored 1 out of 10, so we got 0. 2 students scored 2 out of 10, so a frequency of 2. 2 students scored 3 out of 10. 2 students scored 4 out of 10, and finally 2 students scored 5 out of 10. So very easily you can determine that you should be expecting 8 students at your tutoring session. If I said that students that scored 8 and above are going to get a special bonus on the next assignment, how many students are going to be awarded that bonus? Well, we got 3 individuals that scored an 8. We got 1 individual that scored a 9. We got 3 individuals that scored a 10. We're going to have 7 students getting a bonus on their next assignment. So it's very easy to do sums and other mathematical operations on your scores once you have them put into this frequency table. Now I mentioned that the X column, that score column, please read that as possible scores, because one of the things that you will do in this course is you will be using the frequency table to answer different questions. Data will be given to you in a frequency table, and you will be asked to calculate the average, the variance. We'll get into all that later on. But one thing that you already know how to do, and you might be asked, intent, to do this with a frequency table, is summation. So one thing that I've seen happen, and one of these semesters I'll get it where no student does this, is you will be asked to do the sum of the scores. And what happens is that students who don't get into that habit of going the sum of the scores, the sum of the scores, and don't get into the habit of seeing a frequency table and saying, ooh, not scores, possible scores, not scores, possible scores. What happens is that when they're given a frequency table and it goes the sum of the scores, they say to themselves, all right, it's an X. I got to find an X. Where's an X? Ooh, there's an X. Let me start summing those up. We got 10 plus 9 plus 8 plus 7 plus wrong. That's not the answer. That's not the way that you do it. If you want to do the sum of the scores, you have to realize what your frequency table is giving you. It's giving you the frequency that each of these possible scores occur. So the right way to do the sum of the scores is to decode or unpack your frequency table and say, all right, what are the scores? We got 3 people that scored a 10. So we go 10 plus 10 plus 10. We got 1 person that scored a 9. So that's plus 9. We got 3 people that scored an 8. 8 plus 8 plus 8. And you go on with that. So again, this is something, the sum of the scores is a very common move in statistics. Frequency tables, very common way of presenting data in statistics. You're going to come across a combination of the two. So do not fall for that trap where you go, oh, sum of the scores. There's the scores. I'll just sum that column. Remember that these are possible scores. So whenever you see that frequency table, it should click in your mind, ooh, possible scores, so that you don't make this mistake. All right, any questions so far on what we've introduced with the frequency tables? Okay, so another common way to present frequency tables is to also use them, represent the scores, but use it as a percent. So here we have the actual numbers. Sometimes they'll represent it as a percent, where you take the frequency, you divide it by the size of your, the number of your scores, and you multiply that by 100. And usually that's used when your numbers are just unwieldy for the human brain, right? So in this circumstance, 3 people scoring 10 out of 10, I can understand that. 4 people scoring 7 out of 10, those numbers aren't imposing. But if you had thousands of scores and you ended up with 3,487 scored 10 out of 10, 1,862 scored 9 out of 10, then it starts to get a little bit rough on the human mind to kind of make sense of those big numbers. So if that's the case, you can take your frequency distribution table, and you can just change it into percents, which makes it a little bit easier for our human minds. Using the formula, you take the frequency, you divide by the number of scores you have, you multiply that by 100. So that top frequency of 3 then becomes 15%. 9 becomes, the frequency of 1 becomes 5%. 3 8s becomes 15%. 4 7s becomes 20%. And once again, if you do this all correctly, you should end up with 100%. And if you don't introduce any rounding error, it should be very, very close to that. All right, so that's frequency tables. Any questions on that? All right, so once again, frequency tables, very important. We will be using frequency tables as ways of representing data, as ways of showing the scores that we have. So know, again, and remember what a frequency table represents. And when you start working with a frequency table, slow down and realize that it's possible scores and the frequencies with which they occur. All right, so that was the table. Another way to represent these things is with a graph. So we can take the exact same information, we can take the exact same scores, and instead of representing them as a table, which for example is useful for adding up different frequencies, we can represent them in a graphical form, in a histogram, which is very useful for kind of visually interpreting different sets of data. So those exact set of scores. Those same 20 scores are here represented in a frequency table. This is them represented in a histogram, so exactly the same frequencies. So once again, the bars indicate how many people are in that particular apartment. The bars indicate how many individuals attained that particular score. And you can see for our frequency distribution table, nobody attained a score of 0 out of 10. And on our frequency distribution histogram, there's no bar above 0 out of 10 because nobody lives in that apartment. Nobody got 1 out of 10. There's no bar in 1 out of 10. But 2 individuals scored 2 out of 10, and the height of this bar, again, indicates that 2 individuals scored 2 out of 10. So we got frequency there on the y-axis. We got your possible scores here. Once again, possible scores on the x-axis. And we got the height of the bars indicating the frequency that each score obtained. So this is, again, something that's more easily to visually interpret. So if somebody asked me, how many people require tutoring? Well, I would have to come here and I would have to say, all right, how high is this bar? 5 or less requires tutoring. How high is that bar? It's 2. 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 2 plus 2 plus 2 plus 2 is 8. 8 students are going to require tutoring. So you can still unpack it, but it would be a little bit easier to do that if it was in a frequency distribution table. One of the things that histograms are great at, though, the graphs are great at, is kind of getting a handle on what's going on with your scores. So for example, if I was to take a look at this, I would see that in my class, there are 3 distinct levels of understanding in my class, right? Because there's a bunch of individuals here that are not getting it at all. And then there's a bunch of individuals here that are mostly getting it. And then there's a bunch of individuals here that are really getting it. So it seems that in this particular class, there's 3 distinct sets of students. Those who are not getting it at all, those who are kind of getting it, and those who are really getting it. And they're separated, right? You don't sort of kind of get it. You either get it mostly, get it all of it, or you're completely confused. So if I was taking a look at this data, I might change some of my strategies for teaching to say, all right, we need to figure out how to reach these students, and basically don't need to worry about those. So again, it's more of a visual representation. It's easier to kind of get a handle on what's going on with a large proportion of data. All right, so that's the histogram. Any questions on the histogram? So once again, just as a warning, remember that these are the possible scores. So once again, if you see the sum of the scores, do not just take a look at here and say, well, I need to sum x. There's an x, so let me do that. 0 plus 1 plus 2 plus 3 plus 4 plus 5. No, that is not correct. That is completely wrong. If, once again, I said, what are the sum of the scores? Here's your histogram. You would say, I have 2 plus 2 plus 3 plus 3 plus 4 plus 4 plus 5 plus 5 plus 1 6 plus, what is that, 4 7s. So you would have to unpack it to get to that summation. All right, so just a few more things before we have practice time. So you can construct a histogram. That's called a histogram. You'll also occasionally, well, no, not occasionally, but you'll also see what are known as bar graphs for frequency distributions. We're not really going to get into the difference too much in this course here, but I just thought I'd point it out regardless. So a histogram is connected, a bar graph is not. So that's a bar graph. That's a histogram. And you'll see that the histogram here has connected bars. The bar graph does not. And the rule for using a bar graph or a histogram is that if it is impossible to score between scores, you use a bar graph. So this would indicate to me that on whatever this measure was, you can get a 2 or you can get a 3, but you can't get a 2.5. You can't score between those. That's what's communicated with the bar graph. It's the same distribution. You decode it the same way, but it again just tells you that these scores are discrete, they're separate. This histogram tells it that those scores are continuous, that you can get 2.5, 2.1, 2.8, right, 3.7. You can score those. So that's really the only difference between the two. They work exactly the same. This is just like attached apartment buildings, and these are, detached apartment buildings. All right, any questions about anything that we took a look at so far? It's all good? All right, so that's all the new stuff that I wanted to cover today. So we got a bunch of time for practice today, so let's just make sure that everybody is aware of and on the same page. So in terms of the MyStat Lab study plan, there are, in my lab, there's a variety of different ways to get to the mastery points, but there's really only one way to earn those mastery points, and that's through the Quiz Me option. So whether you go through it through the study plan, whether you go directly through the Quiz Me, what I want you to just be aware of is that what I will grade is your mastery points. So you should be able to see in your MyLab, if you go to the study plan or the Quiz Me options, at one point it should have a place where it summarizes for each chapter what your mastery points are. That is what you're going to get in terms of a safety net for your pretest scores. So if you're doing things and you're doing, quizzes, and then you go check your mastery points and your mastery points haven't increased, even though you've completed a few quizzes, that's an indication that whatever you're doing is not being counted towards the mastery points, so you might be in the wrong area of the MyLab. So just bear that in mind in this early going as you're kind of feeling it out. But you are looking for those mastery points. So again, we've completed pretest number 1. If you got 100% on pretest number 1, awesome, way to go. You can still do the mastery points for that extra practice. But if you didn't get 100% on pretest number 1, as long as you get 100% on the mastery points, you will earn 100% on your pretest. I will change your grade in my calculations so that your pretest grade will be 100%. So that's just your safety net for giving it a try, going through that cognitive process of trying to learn the information on your own, which again, psychologists have shown pay off massively, in terms of learning outcomes, but without any damage being done to your final grade. So just be aware of that. And feel free to earn those mastery points. And then, yep.
So mastery points are only earned through the Quiz Me option?
I believe so, yeah. And I think there's something about you can also, it'll update the study plan via homework, okay, I think, in terms of that, but.
I did the Quiz Me option on it.
Yep.
I only missed one of the tests, but the practice button is still there, but the Quiz Me button is gone, but it says I've earned 2 out of 3.
Okay, so.
I definitely need to practice though for a while.
Okay, we can take, we'll take a look at that. But that's exactly what I'm talking about. So you have so right now.
So I just started getting them wrong. I was like, I made so many.
Well, that's a nice indication though. So for example, if you got 2 out of 3 on your mastery points, then I would take as your pretest score the maximum of what you got on the pretest or your mastery points. So if you got, let's say you really struggled, you got 20% on your pretest, your new pretest score right now would be 66%. If you got 90% on the pretest, your pretest score will stay at 90. So doing the mastery points, you cannot hurt your pretest scores, but basically if you want to get 100% on those pretests, if you didn't do it with the pretest, you have to get 100% on your mastery. Yep. Mm-hmm.
I'm still confused as to where I find the Quiz Me option at.
Go onto your module. Go into modules. With my statement. There you go. That's it.
All right. And one other thing that, just because I want to make sure that everybody is kind of getting to this correctly. One of the things that I still haven't figured out in my stat lab is like a student view and how to get that so that I know exactly what your layout is like, what your layout looks like. But I do know that my stat lab is used extensively throughout North America. So there will be assistance on Google. If you still can't figure out how to access something, I highly recommend just Google it. There's probably a YouTube video somewhere that'll show you step by step how to do that. Contact the MyLab help desk, and I'm sure they can walk you through that. And because we do want to make sure that for the effort that you're doing, you're getting those the points that you deserve. Mm-hmm.
Could I also take a pretest again if I wanted to, or does it just do you just do the math?
Yeah, once the pretest is submitted, that's it for the pretest.
Okay.
Yep. So be careful on that too, because you do have multiple attempts to do a question on a pretest, but once you finish a pretest and it's submitted, you can't go back and redo the questions that you've done. Those become submitted. So bear that in mind. There are some kind of it's not foolproof kind of using the MyStatLab, and just be very kind of careful to know whether you can enter, exit out for different assignments. Yep.
But you can retake it. So will that not count then?
You can retake a pretest?
Yeah.
No, I put it so that you have multiple attempts, but after it's due, I don't think you can.
Well, but before.
No, because before.
Can people do that?
It
Can
says on there you have infinite amount.
Infinite amount, but is there like at the end of your pretest something where you like
You can
submit
start
it,
over.
finish it? Oh, you can start over.
Yeah.
Okay.
It does give you a score, like on the grades or whatever.
I was wondering about that because I got an email where a student was
I didn't want to take
apparently
it. I was like
locked out. All right.
did it 10 times.
Well, a bit of a learning curve on using MyStatLab, but if there are issues, they do have a good help department. It is extensively used. There might be, again, YouTube tutorials on how to use it. And if worst comes to worst, send me an email about it. I'll see if I can kind of work things out. Mm-hmm.
The last question I was, I did not see an option as I went along to check my answer before I went on to the next answer. That wasn't an option, like it wasn't.
That's not for the pretest.
Not for the pretest, yeah.
So the
Okay.
mastery discussion panel allows you to do that.
I see.
Pretest.
Okay. And then secondly, there was two of them. They let you go back and look at what you got wrong. And I always like to do that so I can correct my mistakes. But I did not see it. When I went back to the actual numbers and to see what I plugged in wrong, it wasn't wrong. Like, because both of the answers I believe are correct. So do you want me to see after class?
You can. We'll take a look at it. Actually, we're going to have about a half an hour of practice time. I do believe they correct it before you go back and see it. So I don't know. I'm pretty sure that it does not keep your incorrect answers. When it corrects it, it plugs in the correct answers.
Okay.
I think that's just the way that it works.
Okay, there was a multiple choice one that it was showing the one that I answered
It
is wrong
highlights
though.
Okay.
Yeah, so
All right, so
maybe
we can take a look at that.
I was thinking numbers.
Yep.
We'll see.
Yeah. So we can. I mean, in the half hour that we're going to have for practice time, we can take a look at that. All right, just to kind of get to the practice time, wrap stuff up. So again, with the pretest points, make sure that you are earning those mastery points. Coming up, we got pretest number 2. So again, that is due midnight by January 16th. So be sure to attempt that. And again, if you feel that you can't do it, if you feel that you're struggling with it, struggle with it, because that is an important cognitive process that has been shown time and time again to increase learning later on. Even the stuff that you get wrong, pretesting will help you improve on that later on. So struggle with it if that's where you're at right now. But again, just have it in the back of your mind that it's not destroying your grade, because again, you can get those mastery points. All right, homework assignment number 2, chapter 1. That is doubly due apparently on Wednesday, January 16th. Once again at midnight. So for everything in this course, it's always due the day by midnight, the day before we meet. So bear that in mind. And again, just be familiar with your due dates. They are in the syllabus. They are in your MyLab. So there's a lot of moving parts because we'll do a pre-test before we do a post-test. So for example, chapter 1 post-test is not due yet. but Chapter 2 pretest is, because we're moving forward. We're going on to Chapter 2, so I want to make sure that you're prepared for next class. But you haven't yet finished your homework, which means that it's unfair to post-test you right now on Chapter 1. So there will be overlap, so just be aware of that so that you don't get caught unawares and miss, a pretest or a post-test. All right, any final questions on anything that we covered today? All right, so what we're going to do right now is we're going to basically take the rest of this class time for practice time. So if you have any issues with or questions about the pretest that you've done, about MyStatLab, this might be a good time to ask that. If you have attempted the practice Excel sheets and you at all struggled with those and you weren't able to get the correct answers on those, call me over. If you haven't done those yet, now might be a good time to attempt those, just so you have kind of live help if you need it. But basically, we're going to have the rest of this half hour to do anything. If you want to start on your homework, just so that I'm around in case you encounter difficulties, feel free to do that as well. We'll do the rest of this class right now as practice time. But as usual, usually my policy is that if you are all statsed out, or if you feel your time might be better spent somewhere else, feel free to call it an early day. But for anybody that does stick around that needs assistance, just call me over, let me know. And that was all that I wanted to cover for today. So let me know if you need help, and let's get some of this practice going. All right, so we got some of the more basic ones, but remember I told you that if you could do this one here, then you would be in really good stead with order of operations. So let's zoom in on that one. Whoops. Zoom to selection. And let's take a look at how we would actually solve this. So first off, this was not supposed to be here. It's kind of, I guess, an early Christmas gift. But what you want to do in this case is you want to go through your order of operations. And wherever you end up with, that's what you carry into your next operation in terms of the order of operations. So when you take a look at a question like this, go through the steps and just ask yourself, are there anything in parentheses? And if there is, you do that first. So the first thing we see is that there is something in parentheses. There is the scores minus 1. So the scores minus 1 means that you take one away from each of the scores. So in this case, we would use the Excel function, the equals, let Excel know that you're giving it a function. Highlight the score you want to take one away from, subtract 1, and we get that score minus 1. So we highlight 35 minus 1, we end up with 34. And that is our first step. So that is done. We're done with parentheses. That's the only thing in parentheses. And that's what our scores now have become, right? That's our new set of scores. And the key here is that the next step is performed on those new set of scores. So now we take a look, do we have any exponents? And we do. We have to the exponent 2. We have this squared. So it's this scores minus 1 that is now being squared. So it is this column that is now being squared. So we go to the next one over here, and we can just call that squared just to jog our memory. So we put in equals. We're going to give Excel a function. We highlight the score minus 1 because it's the score minus 1 that is getting squared. Shift 6 to get that exponent symbol. 2 is the exponent we're raising it to. And we get this massive number, 3025. Once again, it's the score minus 1 that is being squared. And we do that for each of the scores minus 1. And now we have the scores minus 1 all squared.
How are you doing that? Telling me the rest of it like that without going through separate?
That we'll do next time.
Oh, okay.
Yep, I promise we will do that next time. All right, so now we have the scores minus 1 squared. And again, as we go through the operations, whatever our scores have become, that's what we use in the next step. So now looking up there, the next thing that we do is multiplication or division, we go left to right. So the next thing that we do is that divide by 7. So we take what we just ended up with, and we're going to divide that by, we're going to divide that by 7. So we put in equals, highlight the scores that we just ended up with, divide by 7, so /7 is division, and we get our answers. So once again, highlight the scores that we just transformed into, divide by 7, and we do that all the way down. And then we continue working through our order of operations. We do any multiplication or division left to right. The next thing to do is that multiplied by 2. So once again, we take what we just transformed our scores into, and that is what gets applied to that next step. So we're going to multiply by 2. So we go equals, highlight what our scores have just become, multiply that by 2, equals, highlight what our score has just become, multiply that by 2. And notice that we still have, we still have all of our scores, right? We still have all 12 of our scores. And that's going to happen when you go through these order of operations until you get to summation. So once you get to summation as your next step, so we finished all multiplication and division going left to right. Next step is summation. Once we get to there, that's when you're going to add all your scores together and end up with just one score. So at this point, we're going to sum what we've just transformed our scores into, and we're going to go equals sum, highlight our new scores that happened after all these operations, sum those, and we get 9,037.143. And then finally, we have to do our final operation, which is any addition or subtraction, which is that take away 1. So we do this, whatever our score has now turned into, -1, and then we pop that up into our answer cell, and we scroll on down, and yay, we got that one correct. All right, so that's the step-by-step solution for question number 3. There was a hand up?
It was, but I think you answered it. Why would you do the -1 after you added that column instead of taking each individually -1?
The reason that we do the summation first is because that's the order that was agreed upon by some group of statisticians that got together. So much like any language, statistics and math has its own language. So in English, we decided that Jim kicked the ball is the way that we're going to order verbs and objects and subjects. So Jim kicked the ball, lets us understand it. If you say that to somebody in a different language that has a different order, they'll understand that as the ball kicked Jim. So you need to decide on an order in order to communicate properly. And for whatever reason, statisticians came together and they said, this is the order that we want to do things in. And in order to get to the right answer, we have to follow that order. So whether it would have made more sense to do addition and subtraction before summation or not is arbitrary, really. We just, everybody decided summation is a special case. We'll do that first, and then any addition or subtraction. Mm-hmm.
I don't know if it's proper for me to do this, but you put your like -1 there next to the sum of the scores. I was in some of the problems I was putting the number like under the part where the actual formula was. Is that like, is there any rules about where we should put this stuff, or is it whatever makes sense to us?
Whatever makes sense is where you can put it. The one rule is, and this is mostly for exams, don't go outside of the box. So your functions, my functions are here when I grade exams. If you have numbers underneath or outside of the box, you run the risk of those being deleted when I copy and paste the functions in. So stay within the box. And then the other rule is do not add rows or columns and do not delete rows or columns. So do not do that little move where, you know, you're like, oh, I need more space, insert columns, you know, let me just give myself another column there. That will mess up the formula, so don't do that either.
And is it cool for us to actually do the computations from the yellow box? Like I did my -1 from the yellow box.
Oh yeah, you can do the -1 in the yellow box. Yep. You can actually, I mean, as you get more proficient with this, you'll be able to do more and more steps in a row. So for example, you could program everything other than the summation, everything up to the summation. You can do that all in one column, but that's, you know, once you kind of get to that level at this point, we'll just keep it simple and kind of break it down step by step by step. All right, so any final questions before we wrap up for today's session? All good? All right. Just